All right, so we're going to continue with our related rate problems. Today we're going to look at two specific types, two common related rate problems. One involving a ladder and the other ones that involve lampposts and shadows being cast on the ground. The first one here says a ladder 9 meters long is set against the wall and begins to slide down. The top of the ladder is sliding down at a rate of 0.5 meters per second. They want to know how quickly the bottom is sliding away from the wall when it is 4 meters from the wall to begin with. All right? So in these types of problems, we will always draw a diagram. So what I'm going to do here is I'm going to set up my wall and the ground and my ladder. And you can see that I've created a right triangle. Okay? I'll call this side Y. I'll call this side X. Notice I'm giving those variables, all right, because those things are changing. It says that the top of the ladder is sliding down, so that means the distance from here to here would get smaller, all right, and the bottom of the ladder would slide away. Okay, so that distance would end up going this way. So it would be increasing. And I'll call this side Z. Now, I think it's fair to assume that in this picture, Z represents the length of the ladder. And that is a constant. It's not going to change. So remember we said yesterday that any of the quantities that are changing, don't put them into the formula until after you differentiate with respect to time. This is a situation where this could go in the original. Why? Because it's a constant 9 meters long. The ladder is not growing, it's not shrinking. When it falls down, when the top of the ladder hits the ground, the end of the ladder would be 9 meters away. The ladder is still 9 meters long. Okay? We do know that X in this question, how quickly is the bottom sliding away from the wall when it is 4 meters? So X would be 4. Okay? I can find Y using Pythagoras, but we can also figure out, like, that's not what we're actually asked to solve for. I do need to find it. But they want me to find the rate at which the ladder is sliding away from the wall. So I'll call that dx over dt. All right, how quickly is the bottom of the ladder sliding away from the wall? That would represent the rate of change of x. dy over dt, that's given to me. Top of the ladder is sliding down at a rate of 0.5 meters per second. So this would be, let me just move this a little bit. Give me a little more space. All right, dy over dt would be 0.5 meters per second. And that's going to be a negative because it's coming down the wall. Now, it's not that it has to do with the down or up or left or right. It's actually that this distance, okay, it's going to start out y units long, but as the ladder slides down, it's getting smaller. So that distance would be decreasing. All right, you might say, well, okay, what's the formula that relates these quantities? Well, in a right triangle, what do you think? If you said Pythagoras theorem, you're on the right track. Now remember, we said this distance isn't changing, okay? So I can fill that in. I can fill the 9 squared in right now. It's not changing. The ladder's always 9 meters long, so I can fill that constant in. When I differentiate with respect to time now, I get 2x times dx over dt. I know x. I'm looking for this thing. Plus 2y times dy over dt. They give me dy over dt. That's negative 0.5. I can solve for y. Okay, there's enough information given there to solve for y. The derivative of 9 squared, or 81, would be 0. Okay? So what I'm going to do now is I'm going to kind of backtrack a little bit, and I'm going to find y. I just wanted to do that part first to kind of show you that, well, okay, it looks like I'm good to go here, but then when I get to this point, I have x, I'm looking for dx over dt, I have dy over dt, but I don't have y either, so I still have two unknowns. So I know I'm trying to solve for this thing, dx over dt, so there must be enough information there to find y. Well, to find y, use Pythagorean theorem again, all right? X is 4, y is what we're looking for, z is 9, so I get y squared equal to 81 minus 16, or y squared equal to 65, and that means y would equal the positive or negative square root of 65. Obviously, we're going to choose the positive square root. Okay? So y would be 8 point something. All right? I'll leave it as root 65 for now. We can convert it to a decimal in the end. All right, so now I'm good to go. All right, I can fill in my x value. X was, let's go see, 4, I believe. Yep, x was 4. So it's 2 times 4. dx over dt is what we're looking for, the rate at which the bottom of the ladder is sliding away from the wall. 2 times y, I just found y to be the square root of 65. And I know my dy over dt, okay, that was given as well. That's negative 0.5. Okay, 8 dx over dt. This would be 1 times root 65, or negative 1 times root 65, so negative root 65 equals 0. Dx over dt is going to equal the square root of 65 divided by 8. Okay, so I just added root 65 to both sides, divided both sides by 8. And the units on that would be the same as the units on this, all right, meters per second. Now that's going to be something that's awful close to 1, because the square root of 65 is awful close to 8. If I do some quick calculations in the calculator here, I get dx over dt equal to 1.0075 meters per second. Okay? That is a ladder question. Now remember, in the ladder question, it is okay to substitute the length of the ladder in to the original equation before you differentiate with respect to time. Why? Because it's not changing. Don't fill in the x's or the y's, because those distances are changing. All right? The top of the ladder is sliding down the wall, y is getting smaller. The bottom of the ladder is sliding away from the wall, so it's going to go this way. The x would get bigger. All right, lamppost question, or street light question, okay? We're going to set up a diagram. We're going to let x be the distance between Bigfoot and the lamp. It doesn't have to go, you could switch these, but we'll follow this kind of pattern for the questions we do. All right, let x equal the distance between the man and the lamppost, or the person and the lamppost, or whatever it is that's next to the lamppost, and let y be the length of the shadow. So here's how these diagrams would be set up. We have a lamppost. Okay, shining some light down at, we have Bigfoot. There's the ground. What happens as the light shines down on the Bigfoot? Well, his shadow gets cast behind him here. So his shadow would kind of go like this. So there's your setup. Again, a right triangle. Now, if we look to the question, we have some variables that we need to fill in, and we have some information given to us. All right, it says that we're going to let x be the distance between the Bigfoot and the lamppost. So I'll fill the x here. Now remember, that distance is going to change. The man or Bigfoot will be walking towards the lamppost, so that distance will be getting smaller. It'll be a negative. Or he'll be walking away from the lamppost. That distance from the lamppost would be getting bigger. In that case, the dx over dt would be a positive. And y represents the length of the shadow. Okay, look a little further. It says Bigfoot is 3 meters tall. So I know this big fellow here is 3 meters. And I also know how high the lamppost is. The lamppost is 7 meters. It says he's walking at a rate of 2 meters per second, and he's walking towards, all right, towards at a rate of 2 meters per second. So think about that. We mentioned it a second ago, or I mentioned it a second ago. If he's going towards the lamppost, what's happening to this distance x? Would it be getting bigger or smaller? Well, if he's walking towards the lamppost, it would be getting smaller. So dx over dt, since that distance is decreasing, getting smaller, we'll say it's a negative. And what was the rate? 2 meters per second. So negative 2 meters per second. They want me to find the rate at which the length of a shadow is changing. What rate is the length of a shadow change? So they actually want me to find dy over dt. So the question is, what's the formula? So I've got the picture drawn. Step 1, draw a diagram. Step 2, fill in your given information. Step 3, find what you're being asked to solve for. So in this case, I know it's dy over dt. Step 4 is to find a formula that relates these quantities. All right, and it's not as simple as what we were doing yesterday. It's not like volume, or it's not an area, or it's not Pythagorean theorem. Okay, this one, what we're going to do, or for these types of questions, we want to use similar triangles. So I want to look at the large triangle. So I've got a triangle that looks like this, the big one. So this side would be the lamppost, it's 7, and the base of the big triangle would be x plus y. It's this distance from the lamppost to the Bigfoot, and this distance, the length of the shadow. And we're going to compare it to the smaller triangle. The smaller triangle would use the Bigfoot, who is 3 meters, and the length of a shadow, y. Now you can set this proportion up any way you like, all right? I typically like to go with like x plus y over 7. I go the base and the height of the large triangle, and I say it's equal to the base, y, over 3 of the large triangle. Now the reason that is, look, this would be a right angle. They're both sharing this common angle here. Okay, these are similar triangles. That angle would equal this angle. If that's 90, that's 90. This is a common angle between them. These angles would be the same. That's why I can use similar triangles. And again, sometimes people go 7 over 3 is equal to x plus y over y. It doesn't matter how you set it up. Or you could go 7 over x plus y equals 3 over y. Just make sure that if you put the base over the height for the large triangle, you do the same thing. Common mistake is people would go base over height and then flip it and go height over base. They'd flip this side. But look, I've got the base x plus y over 7, the base y over the height 3. I'm going to rearrange this a little bit. I'll just cross multiply. So if I do that, now I can rewrite this so that it says 3x plus 3y equals 7y. And I'll subtract 3y from both sides to get 3x equals 4y. Okay? Now, what do I want to do? Always, once you have your formula that relates the quantities, you differentiate with respect to time. So this becomes 3 times dx over dt, which I know. This becomes 4 times dy over dt, which I'm looking for, and we're good to go. So this now becomes 3 times dx over dt. That was a -2. And I can solve for dy over dt. I've got -6 equals 4 times dy over dt. Divide both sides by 4. -6 over 4, that's -3 over 2 meters per second for my dy over dt. How do I know it's meters per second? Okay, look at the units. Same as this one. Or -1.5 meters per second. It's equal to dy over dt. Good. Do one more. All right. It's another lamppost question. This one just kind of throws an extra little piece of information in there. A man is 1.8 meters tall and walks away from a lamppost, away from a 6-meter lamppost at a rate of 2 meters per second. How fast is his shadow changing when he is 5 meters from the post? All right, let's draw our diagram again. There's the lamppost. Yikes, that's bad. Better? These don't have to be anything spectacular, obviously, right? This is an art class. But what do we know? Okay, we know that the distance between the man and the lamppost is changing, so I'm going to assign that a variable. Remember, any distances or any measurements that change, always use a variable to fill in there. Same thing here, the shadow is changing, the length of the shadow would be changing. I do know the height, okay? The man is 1.8 meters, and the lamppost is 6 meters. So tell me this time that the man is walking away from the lamppost, so think about what would be happening to this distance x as he moves this direction. Okay, well, x would be getting bigger, therefore dx over dt would be a positive 2 meters per second. dy over dt is what we're looking for. Again, we're going to use similar triangles. And how did I do the last one? I think I went base over height. Base over height, so I'll do the same thing here. Won't redraw them, but look, what's the base of the large triangle? X plus y over, what's the height of the large triangle? 6. It equals the base of the small triangle, y, over the height of the small triangle, 1.8. Now, some of you might say, whoa, 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 what's up? Why aren't you filling this here in for x? Like it tells us x is 5. Well, remember, I can't fill that 5 in right now. Why? Because this is changing. Okay? So that's an illegal move. After I differentiate with respect to time, if there's still an x in the formula, well then yes, I would fill a 5 in. Cross multiply, I get 1.8x plus 1.8y equals 6y. Subtract 1.8y from both sides, and I get 4.2y. So 1.8x equals 4.2. And when you differentiate with respect to time, we get 1.8 times dx over dt equals 4.2 times dy over dt. Now look at, there's nowhere to fill that 5 in. It doesn't need to get filled in, all right? I know that this is 2 meters, positive 2. 4.2 dy over dt. 1.8 times 2 would give me 3.6 equals 4.2 dy over dt. Divide both sides by 4.2. That would give me 6 over 7 meters per second. 36 divided by 2, or 3.6 divided, sorry, 36 divided by 42 would reduce to 6/7, so 3.6 divided by 4.2 would do the same. That's your dy over dt. And if I converted that to a decimal, 6 divided by 7 is either or are acceptable. Okay? So there are 3 more examples, really 2 examples. One is a ladder question, one is a lamppost question or a shadow question. Okay? Sometimes they ask you like the following. They say, there's a little follow-up question. It says, how fast is the tip of the shadow moving? In that case, you have to add these 2 things together. So it would be that the shadow's growing at a rate of 0.86 meters per second, and the man's moving at a rate of 2 meters per second. So I would just add those 2 things. It would be dx over dt plus dy over dt. And that was 2 meters per second plus 0.8 meters per second, 0.86 meters per second, sorry. So that would give me 2.86 meters per second. That's how fast the tip of the shadow would be moving. Okay, so we're talking about just the tip of the shadow moving that way. If he's moving, it's moving with him. All right, you can go to work on these questions. Sorry, the worksheet questions. And if you have any problems, let me know or send a note in Teams and we can work it out from there.